Lesson 1 of Chapter 11 is on permutations and combinations. And as we get into these definitions, let's slide down to the middle. You can see our definition of permutation is right here in the middle. This is how you pronounce permutation. But a permutation right here is an arrangement of items in a particular order. So when you put a set of objects in a certain order, it makes a permutation. This is different than a combination. A combination is when you select a group of objects and order doesn't matter. So as you can see right over here, this would represent a permutation of those four numbers. This would represent a different permutation of those four numbers. So using our vocabulary, it says write a permutation for each set. This first one, there's a permutation because it represents an ordering from those objects. Next one, WAVE 672 would represent one of the permutations of those objects. And then lastly, UOYR represents a permutation of those objects. So again, a permutation is simply an arrangement of items in a particular order. Number 3 says write all possible permutations for the numbers 5, 9, and 8. So I'd start off with 5, 9, 8. Also, if we went with 5, 8, 9, 8, 5, 9, 8, 9, 5, 9, 8, 5, and the last one, 9, 5, 8. So it looks like there are 6 permutations of the numbers 5, 9, and 8. And they are listed right there. So problem 1, using the fundamental counting principle, it says in 1966, one type of Maryland license plate had 2 letters followed by 4 digits. How many of this type of plate were possible? Question number 5 simply says, which set of letters and digits gives the possible 1966 Maryland license plate? Well, it can't be A because this has only 3 digits. You got to have 4 digits in it. B looks pretty good, but let's move on to letter C. We know it can't be C because you can only have 2 letters, not 3 letters. And it can't be D because, again, you got to have 2 letters, not 4 letters. So it looks like option B is our answer. So there are 26 possible letters for each letter in the license plate. There are 10 possible digits for each digit. So using the fundamental counting principle to find the number of possible license plates, we'll complete this expression. There's 26 letters for the first spot. There's 26 letters for the second spot. There's 10 digits for the third spot, 10 digits for the fourth spot, 10 digits for the fifth, and 10 digits for the sixth. Now if we take each of these numbers and we multiply them, that should give us our answer, which is 6,760,000. This kind of reminds me of the other day I was talking to a student of mine, and I said, hey, were your parents helping you with these math problems? And the student responded by saying, no, I got them all wrong myself. Good joke, huh? All right, next we want to talk about factorial. Factorial, you guys have probably seen it before. Looks like this. It looks like an exclamation point. And 3 factorial is simply 3 times 2 times 1. So keep in mind that we'll use this factorial. I'll show you where it's at on the calculator. If we go to the calculator, if we want to see 3 factorial, which we know is 3 times 2 times 1 or 6, you press 3, you go to math, you go over here to probability, go down to option 4, there's the exclamation point. 3 factorial gives you 3 times, let's see if we can get this to work. 3 times 2 times 1, which gives us 6. Keep in mind, though, that 0 factorial is, in fact, equal to 1. We'll talk a little bit more about that in a bit. Let's go on to problem number 2, finding the number of permutations of n items. How many ways can you arrange 8 shirts on hangers in a closet? So think about this multiplication counting principle. So the first shirt, you got 8 different shirts to choose from for that first hanger. Then you got 7 different shirts for the second, then 6, then 5, then 4, then 3, then 2, and then 1. Thus, this is 8 factorial, which is simply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which if we multiply those out, it should give us 40,320. We can verify that on the calculator. 8 factorial gives us the 40,320. So next, the key concept is how we find permutations. And if you look right here, this is how we calculate permutations. Now, permutation of n items arranged r items at a time is done NPR. And so you take the n factorial in the numerator, and you divide by n minus r factorial in the denominator. So here's an example right here. You can see that 10 NPR 4 is equal to 10 factorial over 6 factorial, which is 5,040. So the question is, why can't r be greater than n? And the answer is, n is the number of items you have. R is the number of items you're selecting. So you cannot select more items than you have. Okay, problem 3. It says, how many ways can 15 runners finish first, second, and third? So use the permutation formula and circle the value of n and underline the value for r. So since we have 15 runners, this is your n, and since we're going to give out first, second, and third place, that's going to be your r. So doing the problem down below, you can see that we're going to have 15 factorial in your numerator. In the bottom, it's going to be 15 minus 3 factorial on the bottom. So this gives us 15 factorial over 12 factorial, which gives us the answer of 2,730. Now in your calculator, we have permutation button. So the first thing I'm going to do is type in 15 because I got 15 runners. Then I go math, over to probability, go to NPR right there. And since we're giving out first, second, and third place, we do a 15 NPR 3, and this gives us that same result. Next key concept, number of combinations. Again, combinations is when you select a group of objects and the order doesn't matter. So how we do that is listed right here. We have NCR. And so that's simply equal to n factorial divided by r factorial. And then you also have in the denominator n minus r factorial. So an example is listed right here. If we had 5 NCR3, you'd found it by doing this right here, and you'd get a total of 10 options. So 14 says which is greater, 5 NCR3 or 5 NPR3? Well, 5 NPR3 should be greater than 5 NCR3 because if you think about this, the 5 NPR3, that's going to give you 60, and the 5 NCR3, that's only going to give you 10. Going on to problem number 4, it says, what is the value of 8 NCR3? Well, you can see it kind of worked out here in the middle, and it says which one does not give the correct formula. Well, the correct formula is not this, and it's not this. That's a permutation on the right. So this is the correct way of doing it. However, if we're going to use our calculator, we would simply type in 8 math, go over to probability, NCR 3, and we get the answer of 56. Okay, so 8 NCR 3 gives us 56. Going on to problem number 5, it says a chemistry teacher has a class work in groups to draw the molecular structure of water. Each group submits one drawing. There are 8 groups. The teacher selects the 4 drawings that earn the highest grades. In how many ways can he select and arrange the 4 drawings from left to right on the wall? So number 17 says circle the correct option for this problem. Well, since we're ordering them, order is important. This is going to be a permutation, not a combination. So it looks like we've got 8 groups, and we're going to select 4 of those groups. So there's your N and your R. So how many different ways can the teacher select and arrange the drawing? This is going to be an 8 NPR4, which should give us 1680. It is. So then, it says use the definition of permutation to show why 0 factorial should equal 1. I know that's kind of a weird thing that 0 factorial equals 1. But if you look at number 20, it says circle the equation that shows the fundamental counting principle and the permutation formula for n items arranged n at a time. So if you think about that, this would be the correct option right here. Not this one, and not this one. So, to simplify this, n factorial should equal n factorial over n minus n factorial. And so that should be equal to n factorial over 0 factorial. And for n factorial over 0 factorial, like you see right here, to be equal to n factorial, that means that 0 factorial must be equal to 1. So lastly, what I'd like you to do is to just check off the words that you feel like you understand using this fundamental counting principle, permutations, n factorial, and combinations. Rate how well you feel like you understand these concepts on a scale of 0 to 10.